Alright, and we're back. Sorry about that little hiccup there. It's taking too much time. Math is just so fun that we just have to take a lot of time to do it, don't we? Alright, so now let's lighten things up a bit. Those last two we did, those were difficult ones. It took a lot of thinking, okay? Those ones are what we call depth of knowledge 3. Because you guys aren't just solving to get an answer, you're having to do something with that answer. You're having to talk about those models and why you think they're better to use in whichever situation. So let's lighten it up a bit. Okay, let's do some, if we're given a table, this table right here, can we turn it into a graph? This, you should be like, yes, an easy question. Because, notice we've got an x and a y here, correspond with our x-axis and our y-axis. So together, it has a relationship, and we can turn it into what we call those ordered pairs. -2, -8, with the x value first, y value second. That's an easy point to plot. We go to -2, then down to -8, and draw our point. Okay, same with those. -1, -5, draw our point. 0, -2. By the way, that's our y-intercept. 1, 1, 2, 4, and last 3, 7. Connect the dots, and there's our graph. Going from a table to a graph, and vice versa, back and forth, probably the easiest ones to do. Okay? So, make sure you're trying these ones and doing them without getting that extra help of me doing it for you first, but you're actually trying it on your own. Okay, so pause it if you need to, if you have time. If not, let's finish this one up. So now, we're going to create a table. So first step, your variables in the equation need to match the variables on the table. Now, I'm going to put x and y here. You can swap them around however you want, doesn't matter. Then you need to pick some numbers. I think it's easiest to pick for x, but that's just me. I like to do it that way. You could pick for y as well. Just be smart about your numbers, okay? That's the only thing. So I usually try to pick small numbers that are going to be easy to deal with. Something like -2, -1, 0, 1, 2, 3. Okay? Then I'm going to plug in just 3 of these so I can get an idea of what my pattern is. Okay? I chose numbers that are small and I made them so that they were a pattern. I'm adding 1 as I go down my columns each time. Okay? I make a pattern. Then you take your equation and you plug in the number x. Remember when we did the x and y intercepts? Okay, same concept, just with different numbers. Okay, we're doing the same thing. Like this one right here. That's going to be my y-intercept. We can even do that one first. I can plug in 0 for x and figure out what's the corresponding y value for that. 0 plus 5y equals 30, so 5y equals 30. And yes, that is a 5, not an s. Divide by 5, and y equals 6. Okay, that would be my y-intercept. Now let's do some numbers that we've already chosen. So let's do -2. 6 times -2 is -12 plus 5y equals 30. Add 12 to both sides. We get 5y equals 42. Divide by 5, and we get a horrible, ugly looking thing. Okay? 5 can go into 48 times with 2 left over. Okay, 8 2/5. Now, you guys probably won't want to do the decimal. It doesn't matter if it's, decimal or not, but it would be 8.4, almost 8.5. Okay, that we can probably deal with easier. Then we do it for -1, so I plug in a -1 here. And do the same thing. 6 times -1 is -6 plus 5y equals 30. Add 6 to both sides. 5y equals 36. Divide by 5. We get y equals 36 over 5, which would be, what, 7 1/5? Okay. Which would be 7.2. Now, can we spot a pattern as we go down? Once you have those 3 y's, we can look for a pattern. And just like we found the x and y intercepts on those graphs, we're finding the points. Okay? So 8.4 to 7.2 to 6. So it looks like to me that we're subtracting 1.2, aren't we? Because 8.4 minus 1.2 would give us 7.2 minus 1.2. So 6 minus 1.2 would be 5, 4.8. Minus 1.2, 3.6, 2.4, and so on. Now, is that the best pattern? Not really, but we could continue our table if we wanted to, and we'd come up with 1.2, then 0, then negative 1.2. Okay? Notice that we do have a couple nicer looking numbers, and I could have modeled my table differently. I could have modeled, looks like if I counted by fives, we might have had nicer looking numbers. Okay, so if I would have went 0, 5, 10, 15, that might have turned out to give us nicer looking numbers. Okay, but there we go. Table, equation to a table, just like that. Alright, now, given a table, find an equation. Now remember, we've got two types of equations that we've learned, recursive and explicit. We'll take either one. Okay, for recursive, remember, it's based off of the previous. It connects the y values based off which number you're talking about. And we typically say it like this. We'd probably want to say n and f of n. Okay, we'd go f of n, so the next number equals f of n minus 1, the previous number. And what that means is this. Let's say I wanted to find, we'll call this a fifth term. So I put 5 in for n. Okay, if I put 5 in for n, it would be 5 minus 1, which would be f of 4. So what that is saying is my answer to, because f of 5 means my answer when x is 5 is based off that previous answer, f of 4. And I know that's a bit confusing. We will talk more about that probably, but that's really what it means. Okay, so f of n equals f of n minus 1, and then what's the pattern? Okay, well, 5 to 10, or we could add 5, but that wouldn't get us to 20. So what else can we do? We can times by 2. Is that working? Yep. Times by 2 each time, so f of n equals f of n minus 1 times 2. That's half of our equation. The other half now is we've got to have a point to tell us where it is. Because if I just times by 2, that could give me any number. So usually you pick that first one. You could pick any of these sets, and you go like this. F of 0, my 0th term before I start, is equal to what? Output value? 5. That's the whole recursive equation. That together. And that works. That's an equation. We can use that. We can use that to figure stuff out. Okay? But it does connect mainly those with a little bit of that. Now the explicit, remember, the explicit is great because it connects this value with this one. So if I plug in this value, it's not a result, it's the actual number will get me mine. So to do that, we take a look at our starting point. And we could do f of n again, or f of x, or y. Any one of those would work. Okay, you guys probably like y better, so we'll do that one this time around. We say, where do we start? Well, look when x is 0. When x is 0, that y value is where you start. And then what are we doing to that y value? We are timesing by 2 each time. Okay? So we'd go times 2, and then we'd put our variable in there. Now this one's actually one we haven't dealt with yet. The variable actually sits up here, but if it were plus, it would sit down there. And apparently that's my mistake. So it would look something like this. Okay? Now let's just say, for our intents and purposes, this was adding 2 each time, instead of that weird multiply. Then you'd go plus 2, and then your variable x. Because we keep adding 2, how many times? We don't know. X amount of times. So we put the x there. Now you could rearrange that and make it 2x plus 5 and make it look slope-intercept form. That's fine as well. But either one of those equations would work for us. Okay? Alright, last problem. We're going to take a story problem. make an equation, a table, and a graph from it. Now, I always like to start with my table. So let's start there. So Prunella starts a YouTube channel depicting Pokemon battles she's involved in online. Her friends and family make 2 followers the first day. Each week she adds 3 followers. So we're talking about 2 groups. Followers for her YouTube channel and time, right? Time in weeks. And her followers. Okay, subscribers I suppose would be the proper term. So how many did she start out with? Well, before she really got it going, she had 2 followers that apparently make up her friends and family. Now, each week after, how many followers are adding to that? 3. So we're adding 3 each week. So it would be 5, 8, 11, 14, and 17. Okay? So for every 1 week, we get those 3 followers. Now, we can graph that pretty easily, right? So we could say weeks and followers. If you wanted to, you could call this X and Y. Call this X and this Y. It's up to you. Just label it whatever you leave it. So 0, 2 would be our first. 1, 5. 2, 8. 3, 11. And so on. Now, a few ways you could find an equation. My favorite way, and this could be recursive or explicit. So recursive, we'd say f of x equals, or n, f of x minus 1. And what did we do? We added 3 each time. And where did we start? We started at 2 with 0 for our input. Okay, that's an easy way to do that. Okay, but I would probably prefer the explicit. I like the explicit better, and that's something we need to get better at. So one way we could do it is say, well, we start at 0, 2. So I'd go y equals 2. And then what did I do to 2? Well, I added 3 each time. How many times? Down until we got to this variable, right? So we did it that many times, so I times it by x. Okay. You could also use your graph. Some of you may be able to remember that slope-intercept form, which is basically what I just found, just backwards, and say, okay, where's my y-intercept? Well, it's right here at 2. So I know it's y equals something x plus 2. What's my slope? Well, I'm going up 1, 2, 3 every time I go to the right one. 1, 2, 3 every time I go to the right one. Slope is y over x, so it would be the vertical 3 over the horizontal 1, which we'd simplify to 3. Okay, same thing I wrote, just backwards. So, there you guys go. Hopefully that helped you out and you're ready for that test, and we will see you then.